Electrical Engineering Solutions organized by the Electronics and ICT Academy NIT Warangal in association with the Department of Computer Science and Engineering SRM IST Vadapalli campus. To start this event, I kindly request everyone to rise for the Tamil Thailand. I call upon Ms. Manjushri and Ms. Dhanalakshmi to sing the invocation.
நிலமடந்தை எழிலொழுகும் சீராரும் மதனமென திகழ்வரத கண்டமெது எக்கணமும் அது சிறந்த திராவிடனர் திருநாடும் தக்க சிறு திரு முதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் வணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறமியந்து செயல் மறந்து வாழ்த்ததுமே வாழ்த்ததுமே வாழ்த்ததுமே.
Thank you, Ms. Manjushri and Ms. Dhanalakshmi, for the beautiful introduction. To illuminate the path of knowledge and wisdom, let us light this Kuttuvalakku together, symbolizing our unity and shared hopes. I invite the dignitaries to come forward and perform the lighting ceremony. May this light lead us forward towards brilliance in all our endeavors. Thank you all for participating in this cherished tradition that marks the beginning of something special. Please take your seats. It is now my honor to invite the respected Dr. S. Prasanna Devi, Head of the Department of Computer Science and Engineering, to deliver the welcome address.
A very good morning to respected dignitaries on the stage, participants of this Tech Fusion. So basically this event is titled as Tech Fusion 2.0 because it's a culmination of two events which is happening today, organized by the CSE department. One event is this FDP being hosted by the CSE department, Sync Club, in association with NIT Warangal, which is a short-term training program, which is a 6 days program. And the second event is happening in the lab, that is Tech Odyssey for the school students. So we have combined two events, so it's called as Tech Fusion. And coming to the event, little details about the event, I'll come to it later. So you should be wondering that there's a different photo in the banner and there's a different dignitary sitting on the stage. I'll tell you what has happened. The chief guest for the day, Dr. Uday Bhaskar sir, his train is delayed by 12 hours. He was supposed to reach Chennai yesterday night. We have booked him accommodation and all to reach here and stay by 11 o'clock in the night. but it so happened that his train is delayed. It's coming from somewhere in North India, and there's a still delay, and he'll reach here by 12 o'clock only. So this has happened. And to come from NIT Warangal, that is Warangal to Hyderabad, by road, and then take a flight and come here, again, it was a very tedious. We couldn't get tickets within a short duration of yesterday night itself. So we requested Adi Lakshmi ma'am sitting here as a chief guest. She's working as a chief data scientist in Capgemini. She's one of the resource persons of this FDP for the day 3 actually. But then we requested her today morning only, and thankfully, ma'am, you accepted to deliver the first session. Thank you very much for that. A kind acceptance. Clear example of showing a friend in need is a friend indeed. She just told me like, okay, I'll apply leave, I'll come to your college, no worries, that's it. And she asked me to send the PPT, and she has accepted to deliver the contest. Of course, PPT is not a big issue because she herself is a chief data scientist. So that technical part, she'll take care of it. You don't have to worry. But for the inaugural session, there's a small change in guest. This is the background of this, today's inaugural ceremony. So coming to Adi Lakshmi ma'am, she has got both industry and academic experience. She was with academia for quite some time, and then she moved on to the industry. And in the industry, she's working as a chief data scientist, taking care of all AI/ML related projects and deep learning projects as well. So any doubts you have, she's the right person to teach you in depth about this deep learning. So for this next 6 days, even if you are a fresher, you don't have to worry because the session is organized in such a way that you start from the basics of machine learning and you dive deep to develop a computer vision based project. So this is how the agenda is planned, both for the faculty members, research scholars, and for the students present here. So you have a very good learning experience. So that much I can assure you, because all the resource persons that are lined up, be it Deepan or Deepan is from HCL Tech, and then he's a senior data scientist. And yet another person, Jay Ganesh from Valio, he's again a project manager. And of course, Adi Lakshmi ma'am and Bhaskar sir. All of them are very good experts in this field of machine learning. Okay, so with this guarantee, I welcome the Dean, Dr. C.V. Jayakumar sir. Thank you very much for all the support. Indeed, every time, yesterday I was continuously disturbing him about all the change in plans. His response to all the mails was so positive. So thank you for that support, and I heartily welcome you, sir. Also welcome the Vice Principal Academics for this FDP and for this Tech Odyssey. Tech Odyssey, we're not having it as an inauguration because the students have to leave early before 3 o'clock. So we started the event in the lab, but then we will have the valedictory alone back again in this auditorium later. And a special welcome to the Sync office bearers, because it's they went to the schools, their own alumni they invited, and it's because of them both the events happening today, which is Tech Fusion 2.0. So I heartily thank all the office bearers of the Sync Club. A special thanks to the faculty coordinators sitting on the stage, Dr. Akila and Dr. Durga. So they both have been pivotal in bringing these two events I should say, to limelight today. So hearty thanks and welcome to both the faculty coordinators. And I also welcome the head of EC department, Dr. Shirley Edward. So I have requested ma'am to be one of the judges for today's tech event happening, the school event happening in the lab. So I heartily welcome ma'am, and a special welcome and to all the participants present out here. So we thought that it is conducted in hybrid mode. So we thought that why not, the resource persons are coming here. So why not the third years take the benefit of it. So we ensure that a few third year students register for this event, and it is, so make the best use of it, not for OD for 6 days, but you should ensure that you learn, you complete the certification so that you pass the examination which will happen. You will be submitting a project as well as the test will be there. After completion only you will be getting your certificate. So with this small introduction, I once again welcome all the participants, all the dignitaries on the stage and off the stage for this Tech Fusion 2.2. Thank you.
Thank you, ma'am, for your gracious and heartfelt welcome. I now invite Dr. P. Durga Devi, coordinator of this FTP, to provide insights into this faculty development program.
Thank you, Vasili. So, good morning, respected dignitaries, esteemed faculty members, research scholars, and all the participants. So I am honored to welcome you to the inauguration of Faculty Development Program on Integrating AI and ML for Next Generation Electrical Engineering Solutions, being conducted by Department of Computer Science Engineering, SRM Institute of Science and Technology, in collaboration with NIT Warangal and NITI. So today marks a significant step in the journey of integrating the artificial intelligence and machine learning into the domain of electrical engineering. As we all know, the world is rapidly advancing and the role of AI and ML in shaping the future of industries and technologies has become the pivotal. So the field of electrical engineering in particular is poised for an extraordinary transformation driven by these cutting-edge technologies. So this FGP aims to equip our faculty members, research scholars and students with the necessary knowledge, tools and skills to integrate AI and ML into the curriculum and the research, thereby enhancing the learning experience for fostering the innovations in the field. So by exploring these technologies, we are not just advancing the education practices, but also preparing our future engineers to solve the real-world problems with smarter and more efficient solutions. So I would like to extend my heartfelt thanks to the NIT Warangal and NIT GUI for the invaluable collaboration and support for making this event possible. So their contribution is an instrumental in providing us with the resources and expertise necessary to conduct this enlightening and impactful program. So as we embark on this exciting journey, I encourage all the registered participants to make most of these opportunities to expand their knowledge, collaborate with experts, and contribute to the advancement of AI and ML in electrical engineering. So let us work together to shape the future of education and technology. So once again, I extend a warm welcome to all the participants, and I hope this FTP will inspire and empower you to embrace the possibilities of AI and ML in creating the next generation solutions. So thank you, and I look forward to the successful and engaging program for the next 6 days.
Thank you, ma'am, for your valuable insights. The distinguished patrons for this event are the accomplished and dynamic Ms. Harini Ravi, Director, Institutional Development of SRM Group, and Dr. Ravi Pachamuthu, Pro-Chancellor Admin of SRM Group. It is under their exceptional leadership that SRM University has achieved international recognition and is now ranked among the top private universities in India. They have expressed their warmest regards and well wishes for this event's success. It is a great honor to have our esteemed chief guest and speaker of today's FDP session, Dr. Adi Lakshmi Vadavalli, a senior data scientist with us today. We take this moment to show our gratitude and appreciation to our chief guest. I now invite our Dean FET, Dr. C.V. Jayakumar, and VP Academics and Placements, Dr. C. Gomati, to present and unbox to our esteemed guest, Dr. Adi Lakshmi Vadavalli.
Now it's our privilege to welcome and introduce our chief guest, Dr. Adi Lakshmi Vadavalli. Dr. Adi Lakshmi Vadavalli is an accomplished academic coach and data science professional with over 13 years of experience. She has served as an assistant professor specializing in data mining and machine learning and has contributed to curriculum development. With a strong background as a business analyst at TCS in the insurance domain, she has worked on improving business processes and customer satisfaction. Currently, Dr. Vadavalli is a senior data scientist at Capgemini. She holds a bachelor's degree in computer science from KL University, where she was a gold medalist, and a master's degree from Satyabama Institute of Science and Technology. She has a PhD in computer science, focusing on machine learning techniques for web mining. In addition, she holds 6 professional certifications, reflecting her deep expertise in data science and artificial intelligence. We eagerly look forward to her insights and expertise as she delivers the keynote address.
Hi respected dignitaries on the stage and the participants for the Tech Fusion. I am quite delighted to be here and deliver the keynote address. So I am expecting that all of you are in your third year and you had some amount of information on machine learning, right? So let me start with my introduction itself, like very brief introduction. Like I started in 2004 after I completed my PE, and then I got in placement like through campus itself into TCS. So I worked there for 4.5 years. I was working in IBM mainframes. Okay, and then after that, we were into testing, and so it was in shifts that we had to work because I was on my family way. So what happened? It was not possible for me to go in the night and so on. So what we did is I had a great passion for teaching. So what I thought was like, why don't I join as a lecturer somewhere? So I tried. I was in Chennai, completely based out of Chennai. So I tried to apply for engineering colleges, and then I started as a assistant professor in one of the college nearby. So with my BE itself, I was trying to teach, and then I realized that okay, so when we are in teaching, we need to have minimum of post graduation. So after 1 year of teaching experience with BE, right? So I then paused there for a moment, and 2010 to 12, I have completed my ME in computer science in Satyabama University. In BE, I was a gold medalist from my branch, computer science, and in ME, I was a third rank holder from Satyabama University. After I completed my ME, I was very passionate about teaching, and somehow like I had an opportunity even to join. So I worked in Satyabama itself for 6 years, 2012 to 2018, and in that process, I applied for my PhD and I completed my PhD part-time in web mining. So in 2018, I was actually, there is a program called Train the Trainer. Okay, so even as part of my ME, we have studied computational intelligence, machine learning, and we were teaching both BE and ME students about all of these subjects, right? Python, data analytics, and all that. So when I was there working, right, there was a Train the Trainer program. Okay, so in that IBM was coming. IBM was actually doing the Train the Trainer program. So I got into that. So they used to train us so that we can train the students in data analytics and so on. So, so that helped me a lot, even with the practical use cases, and we were training the students. And I saw students getting placed with very good packages, like you all know, right? 20 lakhs per annum, 40 lakhs per annum, and so on. So not only because of this motivation, but also because of the most of the happening, the potential in the data science, right? I was quite fascinated. I thought like, why don't, because I already have an IT background, why don't I try? So it is actually the transition from academics to back to industry is little tough, because they always expect, even though you have some amount of experience in IT, right? They expect that you have the knowledge in data science. So I was again brushing up myself, doing real-time projects, updating my GitHub profile and so on, and then I tried for 1 year, and I was lucky enough to get into a startup company as a junior data scientist. So, and I was also around 2018 November, so I was also having access to all the cloud services. So I was using Azure and AWS cloud, and we were working in a deployment team. So that is the other turning point for me. So from 2018, then I worked in startup companies till 2020. In 2020, I joined Capgemini as a senior data scientist, and till now I'm there. And as part of why I'm telling my story is like, see, there is nothing that is impossible. Everything is possible. Only that you need to have an intention. Okay, what is that you want to learn about? Now you can see that there is a lot of boom in terms of Gen AI, and we need not not like just 2 years back, right? You need not know the. See, I'll tell you one question. What is the best programming language now? What programming language should you learn? Yeah, anyone? What is the programming language that is like 99% very important that you need to know? Python. Man is studying Python. Anyone else? See, as according to me, right, you just have to know English. English is the programming language now because you are already having GPT and all, right? So irrespective of the programming language, I'm saying programming language is English, but you need to have the algorithmic skills and the strategy for designing your algorithms, problem solving skills, creativity. These are the things that are very important. When you have a business use case, how do you convert the business use case to ultimately a problem solving, a use case, problem solving use case? That is the skills that you need to have. You need not, I mean, you need to know only the syntax to an extent and the semantics of the programming. What are all the control structures that it has, and so on and so forth. But it is same, right? Be it Python, now it is Python, then you have Scala, then you have Go programming, some R. So it keeps on changing, you don't know what comes next. Okay, so you learn very well Python and you say that, okay, later next one comes, right? You can't say that I can't code, right? Now you are expected like the sky is the limit, everything under the sky. Okay, so what I'm saying is, no, I'm not demotivating you to learn not to learn the programming language. My intention is that everything is there, okay, but what is that you need to concentrate on? You need to concentrate on your basics, okay, because it's very tough when you have a real-time use case, right? It won't come in a typical way, okay, you will have to analyze it. What is the problem at hand? What value, even if you are investing so much cost and all, what value do you bring to your clients is what you need to look at. Okay, so all these things are very important. Okay, so one more thing I noticed in the current generation is like they are very distracted. Okay, so people who are focused are able to achieve their targets. People will have intention. Everybody here will think that, yeah, I need to study well, I need to get good marks, I need to get placed. But the problem is distraction. Distraction in many ways. The mobile phone itself, right? So every minute you get some message or the other you see. So what happens is that the moment you try to distract yourself, right, you will not be able to, you will not know, your energy will be wasted. Like you are consuming some energy to look at that, respond to that, it's gone case. So the task that you are at hand will not be to the extent that you can put in, right? So my main thing is like as students, right, focus and sacrifice is very important. These two things. Focus and sacrifice. What you need to sacrifice? You need to sacrifice all of the comforts. Okay, having nice food, nice sleep, okay, nice AC, won't work. If you have to, I mean, don't think that I'm talking traditional mindset, but only if you sacrifice, then only you will get the efforts, then only you will see the results. Focus and sacrifice. These two things you need to make it as your own habit, as an atomic habit. Otherwise, it's very tough. With focus, whenever you're studying, right, after you attend your classes, okay, you need to make sure that you study your subject then and there, that day itself. Whatever is told, right, revise so that it stays in your RAM and goes to your hard disk. Okay, and when you are studying, make sure that you don't have your phone. You form a bubble around yourself. Okay, and then you study quietly, not even, no single point will be able to disturb you. You have to make yourself that environment in which you can work. It can be for 3 hours, 2 hours, doesn't matter. People will say you need to work for 16 hours and all, no need. 3 to 4 hours, solid, enough, focused. Or if you are not able to study, morning 2 hours, evening 2 hours. Please plan properly. Focus study will actually give you results. The second point is that, sacrifice. You need to sacrifice whatever it is like, right? Whatever you are doing in the current things, right? Whatever that you can forego to get your goal, right? Those all you need to sacrifice. Okay, if you are sleeping with all that comforts, eating nice food, right? That will not give you concentration. Okay, you have to eat to an extent that you survive. Okay, not that you eat too much, right? So all of these things you need to keep in your mind. The other thing I can tell you is like, now there is a lot of everywhere in every irrespective of the domain, whether it's in electrical engineering, mechanical engineering, civil engineering, or whatever, right? Everybody have to have a basic knowledge of AI and how do they use this in order to better their things, even in bioinformatics. Correct? So everywhere there is a boom of the AI. So being your electrical students, right, you need to concentrate more on how do you use it for your own benefit. So you need to pick a use case, a generic use case that can be applicable to industry And then how do you solve about using AI? That is the challenge you need to take. Make your own small projects that you can present in front of the people when they come for the interview, right? So you need to have all of this. Anyway, I know SRM is already kind of doing that profiling, right? You will make your profile. You'll have to do a lot of internships, NPTEL courses. Apart from that, I'm saying update your GitHub account with good projects that you can showcase. It need not be 10 and all, at least 1 or 2 good projects which you can talk about it on your own, right? Collect the data and whatever you can do from that. That will help you get your job in your interview. Okay, because you need to try to see that if there are like, everybody is doing it, everybody is saying that they are into it, but how are you unique? That unique USP you need to have, unique selling point for you. So how do you create that? You need to think. You saw the movie Pushpa, right? So he has his own brand. So you have to create a brand for yourself. How do you do that? You need to think about it. How am I different from the entire crowd? Okay, so if I am to get selected, and you have to always keep in mind that when companies are coming, it's always a process of rejection. They don't try to select you because there are like 10,000, 20,000 students from one college. Okay, what they do is like they put in initial written test. They try to reject candidates rather than selecting. If your CGPA is below some point, right, reject. Okay, so interview is a process of rejection rather than selection. Initially they'll fix their mind that will reject unless and until there is any USP for you, unique selling point that you can tell them. This is where I am good at from the entire crowd. This is the value that I bring to you. Unless and until you have this, you will not be selected. Competition is so much. So please devote your time for a successful career. Now, if you are able to have it right, then you know the basics very well. Then you will have a great life ahead. Thank you. Thank you so much.
Thank you, ma'am, for your inspiring words and for gracing us with your presence today. As we near the end of this inaugural session, I now request Dr. K. Akhila, Assistant Professor CSE, to deliver the vote of thanks.
Good morning, everyone. It is with great pleasure and gratitude that I extend a warm welcome to all of you as we kick off this exciting Quadric FDP on integrating AI and ML for next generation electrical engineering solutions, organized in collaboration with NIT Warangal. We are thrilled to have such a distinguished group of participants, speakers, and experts joining us today. First and foremost, I would like to express my deepest gratitude to our esteemed chief guest, Dr. Adi Lakshmi ma'am, Senior Data Scientist at Capgemini, for graciously accepting our invitations on such a short notice and for agreeing to share her profound knowledge and experience with us. I would like to express our sincere thanks to our respected Dean Sir, Dr. C.V. Jayakumar Sir, and our VP for Academics and Placement, Dr. C. Govati ma'am, for their continuous encouragement and support. Their vision and leadership have been instrumental in organizing this FCP and enabling us to bring this impactful program. A special note of thanks goes to our organizing committee, faculty members, everyone involved in putting this program together. Your dedication, hard work, and tireless efforts have been the driving force behind this initiative, and we are grateful for your commitment. Our heartfelt gratitude to NIT Warangal for the collaboration in making this event possible. Your partnership in organizing this FDP reflects the importance of fostering academic collaboration and knowledge sharing across institutions. Finally, I want to thank all the participants for taking out of your busy schedules to be a part of this program. We believe that this FDP will be an excellent program for enhancing your knowledge and skills in AI/ML, and we look forward to a week of learning, interaction, and growth. Once again, thank you for being here today and wish you a grateful and engaging week ahead. Thank you.
Whatever kind digital image processing techniques that you will apply, filters that you will apply and make the system understand the pattern for recognizing a cat. Correct? Okay. And then what happens? Once the training is done, okay, that is what you did. That is what your code is. There is no explicit programming. I am not putting like if something, no. Okay, there is no for loop, there is no if statement. That is what I said. That is not rule based. Okay. This is what I meant by machine learning. Machine learning means there is no explicit programming. I won't say that, okay, if image is equal to this, it is a cat. Did I? No. Implicitly, by its own self, using so many other techniques, the machine is able to understand the pattern. Is it the same way how we understand a cat? No. The way we see when we look at a cat, our brain is something like different. We say, but the machine understands differently. It will have to store all the different patterns. Even our finger, thumb impression recognition also in the mobile, right? You have to give in different ways, correct? All different ways, and one point it needs minimum of different coverages of all the entire area, so that anytime whenever you are looking, right, you'll be able to understand. Okay, so what will happen there? Machine, you are training the machine, and then what you will do? You will do it testing also. Okay, now that I train on cat images, not so cat images, let me test it. Now give a new set of data, and then what happens? It will tell you whether it's cat or not. It may sometimes go wrong, and it may be sometimes right. And very important point, it may sometimes go wrong, correct? Correct? But when you are explicitly programming, you will never go wrong. If I am asking n factorial, okay, and in your examinations, hacker rank and all, you are doing all this Python programming, if it will run some 6 or 10 test cases, right? If any one test case is failing, you are failing. You don't get marks, correct? So that is what. But in machine learning, when you build a model for recognizing something, there is no 100% accuracy at all. There is no 100% accuracy. I can't tell that the machine is able to identify, give me anything on earth, it will tell you whether it's a cat or not. No. Sometimes, if I give you something like very similar to cat, right? Some tiger images, I'm just making out, okay? I'm not an expert in recognizing or distinguishing cats and tigers, but if I give something like a tiger image and ask it, it may say it's a cat, correct? Okay, so what I basically want to say is, how is machine learning different from normal programming? In two aspects. One is that you will not have any explicit programming, and there is no 100% accuracy. Okay, these 2 points I wanted to highlight. Okay, next we'll go ahead. So machine learning is like making the machines learn the different patterns, and without explicit programming, you are able to get the output. Okay, so for any machine learning, right, there are some, an IIT professor, I think Nitish Karpa in NPTEL program, he has once given a very good elements that are required in order to actually proceed with machine learning. What are all the 6 jars? He named it as 6 jars of machine learning. He's a professor from IIT Madras, and I have like so much. So I usually tell this everywhere whenever I get started with machine learning. It's very important for us to understand what are the 6 jars of machine learning. Okay. If somebody can attempt also, I would be very happy. I would like to cover what are the 6 jars of machine learning. Okay, jar number 1. Any guesses? There are 6 elements of machine learning. Basic machine learning. I'm not going in depth also. What are the 6 jars of machine learning? Yeah. Yes, please. Feature selection. Okay. Feature selection is a process. Completely agreed. But it's not one of the jars in machine learning. First of all, whenever you need to perform any machine learning model, whenever you need to build, what is the basic thing that you need? Mathematics is internally correct. Mathematics is correct, but what? Data is the number one thing that you need. For any machine learning program, you will have to need data, correct? Without data, you can't do anything. Now people will come to me and tell me that, okay, build this one for detecting something. I will ask first, where is the data? And is the data sufficient enough to build a model? I don't know, I need to check. Because for any predictions that I need to do, or any classification, any task, for example, I need sufficient amount of data. Okay, there are so many aspects for data itself. I can talk long on data also. You need correct, first of all, data availability should be there. Correctness of the data should be there. Okay, and availability, how much of it is available for us to use. Data privacies and all that is there. How much of this data can I expose and so on. Okay, so there are so many aspects of data. But one thing that you have to remember is that basically data is divided into 2 things, structured data and unstructured data. Okay, and also semi-structured data. Structured data is nothing but anything that you have like rows and columns, right? Excel files, CSVs, JSON formats. Okay, all of these text files is also structured data only. Okay, and anything other than these, right? The PDF documents, images, videos, audio files, all of these things are unstructured data. Semi-structured is somewhere in between. Okay, so you have these three different kinds of data, and also data is like publicly available data. Some data is like confidentiality is there, like you cannot use or you need to refer when you are using the data. Okay, and you also have, you believe it or not, we were actually thinking of building one model where, depending on the voices, right? Like whenever in a customer call center, the data input data for us is like wave file .wav or MP3 and MP4 files, audio files. Okay, so we had a project where we had to build an application using the customer chatbot calls, right? We had to analyze the data and know like what is the purpose of the call, how many people were actually talking, remove the background in that, okay, and then identify who are the speakers, okay, and then what is the sentiment in that, what was the actual purpose of the call, how did the tone of the customer agent is, was it positive, negative, neutral, was he trying to help, okay, finally how was the closing of the call, so all of these things, okay. The basic challenge we had was we did not have any data for training. Okay, so sometimes whatever data we need to take for building is paid. Okay, how these cloud service providers like Amazon, Azure and Google, how they are, one of the things that they are earning is in terms of this data services also. If you see Amazon Mechanical Turk, their data sets are available for all different kinds of problems, but you need to pay for the data set. The data collection itself is a huge process. You can do an R&D in a data collection itself. What are the different ways in which you can collect the data? And you can actually, if you have collected data and the data quality is good, you can actually put it out you can earn money through that. Okay, that's why you have to be very, data is very crucial for any particular thing. Okay, even as Indians, right, we need to understand that in every social media platform, or in any app-based things, right? Never share your data so easily unless and until you know what is being happening. Where is it stored? Is it confidential or not? Please don't install the apps and then give your data freely. Okay, you have to be very careful unless and until it's required. Okay, so what I'm basically saying is there are paid data sets as well. So if I had to do a project, then I had to buy the data, which is very costly. It was around 200 euros, 300 euros. Okay, so basically, there is data which is very important for the entire process and it is available publicly. There is confidentiality in the data and there are paid data sources as well. Now, after data, I'll proceed to the next jar. Okay, what is the next jar after data? Framework or models. Actually, model is coming. Okay, model is coming. I'm exactly putting the way ID professor was putting. Third is model. The third part is the model. Okay. I'll come to model again. There is a second part here. Yeah, very good. I think you must have had now from the internet, you must have seen the 6 stars of machine learning, right? Very good. So at least I know that this is very important for you. Tasks, very good. So what are these tasks? Tell me. When you have the data, what are the tasks? Yeah? What to do with the data? Exactly. Super, correct. It's not a big question. What to do with the data is your task. Can you give me some examples of tasks that we perform on the data? We do predictions, forecasting, okay, and then we do classification, clustering. These are all some of the tasks that we are performing. And also there are recommendations also. Recommendations also that we are doing on this, right? Any of these things will come under task only. Say for example, in the Amazon, right? You're every day going and buying. Okay, so the customer profiling is being done. Okay, they profile the customers based on your buying patterns. Okay, you go there, you buy certain things. What they'll tell, initially you create an account, you buy something. Later when you go inside, right? We'll tell you, okay, based on your buying pattern, you bought this. So you can likely buy this also. If you bought a cycle, right? They'll say, okay, you can buy a basket along with that. You can buy these things along with that. Correct? If you buy a mobile phone, they will tell you can buy a pouch for the mobile phone. So you will try to sell you other things, earbuds. So based on what you bought, that is called association between the data items also. Correct? And there is also a recommendation. Suppose in Netflix and all, you're watching certain types of movies, maybe based on the language, genre, and the kind of actresses that you are trying to watch, right? It will store your history, and accordingly it will tell you like, okay, you watch this movie, you may also like something another. If you prefer violence, right, keep on telling you violence movies. If you prefer horror, it will advise you, okay, this person is interested in horror movies. So it is also called as a recommendation. So there are different kinds of tasks, okay, that you can do. Regression, classification, study, and recommendation. That is very important. Okay. So the next is model. When you say model, what is it?
So how much are you getting for today?
Model means what?
How much we are paying for you?
Yeah, in general, model is nothing but an approximation of reality. Okay. So whenever in real estate, if you're investing, like to put very simply, some builder is coming up with a plan. What he will do? He has a plan in mind. He has a model that he built. He'll say, so you have a look at this. He'll make a small model of the entire thing, right? This is tower A, B, C, D. So this is how it looks. This is the facing. So that we form a visual representation. Same thing here also. In machine learning, model is very, very, very important. It is the heart of the entire process. Model is representation of the reality. Okay. So what happens is like in machine learning, a model is always represented as a mathematical function. Y is equal to f of x, where x is a set of inputs and y is the output. Okay. Y is equal to f of x. That's it. As simple as that. We are trying to build that f of x. If x are all the input features, if x is all the input features, I am trying to build a function f of x, and I am trying to get the output variable y. For example, if you want to say your height and weight are there. Okay, maybe based on your weight, I can tell your height, or based on your height, I can tell your weight. Both of these variables are kind of continuous variables. Okay, so x will be your height, and y will be my prediction of your weight. I can come up with a model, approximate model, in which if you keep giving me data, I will store all the heights and weights of individuals for 1,000 people, and you are giving me a new individual and coming. If you give me their height, I can tell their weight. Okay, that is one example I am saying. Y is equal to f of x is a model that we are trying to build here. X is the input and y is the independent variable, that is the output. X and y both can be either continuous or discrete, or it can be categorical also. Hope you know the difference. Okay, x is a continuous variable means that values can be decimal points, right? Y can be continuous or categorical. Categorical means it will not be numbers. It will be either like, yeah, gender, male, female, or the states of India, something like that. Okay, so it can be categorical also. So what is the fourth one here? Data, task, model. Yes.
Algorithm?
Yeah.
Algorithm.
Algorithm. Okay. So actually, algorithm is not a part. Yes, it is an important part, but it is not coming in the 6 jars. The next one is the algorithm is coming as learning algorithm here. Okay. Learning algorithm. Yeah, correct. Very good. Loss function. Okay. So what is loss function? I don't know if you are already having, but see, what did I tell you? Approximation of reality. A model is an approximation of reality, which means that what I already told you that in machine learning, you will never have 100% accuracy and all, correct? So whenever we are trying to predict something, okay, there will always be certain error. Error is for sure there. What is error? Error is nothing but the difference between the actual to the predicted. Okay, if I say that depending on the weight, if I am saying height, right, it is only an approximation. I can't tell you exactly. If I tell you my height, my weight, and then they ask me to predict my weight, okay, Okay, they tell my height and ask me to bring my weight to the model. There will be always be certain error, for sure. Okay, so that error we need to minimize as much as possible. That is where optimization techniques are coming into picture in machine learning. The main objective of any machine learning, okay, as I told you, it's always an approximation of the reality. It is never 100% accurate, so there is always an error. So our objective function is to minimize the loss. Minimize the loss. So how do we do that? With the different kinds of loss functions are there. Okay, mathematical loss functions are there. Basic loss function is nothing but root mean square error, right? RMSE, MSE, MAE. Okay, so there are different kinds of loss functions are there. Binary cross entropy loss and so on. So choosing your loss function will also determine how you want to minimize that. I mean, how do you want to represent your loss function? How do you want to calculate your loss? Nothing but error. Okay, next one, learning algorithm, as you all told me. Okay, so tell me the most important and revolutionary learning algorithm. I think this set of people are little active compared to that. Can I have little silence please from there? Yeah, can you tell me any learning algorithm? Any learning algorithm? There is one learning algorithm which is like it created a revolution itself. Yeah, these are all algorithms. Yeah. There are different kinds of machine learning algorithms. All of that are coming. But when I say learning algorithm, right? See, it's always referring to that particular algorithm. Okay, so in the process of minimizing the loss, what will happen is that I will have to form an equation. Say for example, if it's a linear, no? Y equal to mx plus c, where c is a constant, m is the slope. Okay, or it can be sometimes y is equal to ax, a1x plus b2y, c3z and so on. Where x, y, z, I mean, I'm trying to have a mathematical function as good as that, right? The thing here is, I need to find out the values of a1, b2, a1, b2, c3, all the coefficients in such a way that the error is minimized. My objective is to minimize the error. How do we minimize the error? I will be able to minimize the error in such a way that I have optimum values of a1, b2, b3. Okay, where my y and y cap becomes same. Y is nothing but the actual. So y cap is the predicted. Okay, so I want to minimize, make it 0. So how should I choose my? That is the learning algorithm. Your algorithm should be in such a way that you find out the coefficients. What are the coefficients that are to be put in your model? Okay, so that the error becomes minimum. So that is the learning algorithm. Whenever they are asking you about the learning algorithm, right, you need to understand and thoroughly learn stochastic gradient descent. Gradient descent. Okay, please remember gradient descent. If possible, try to learn this algorithm. Okay, that is the one which created it. These are the very, very important basics. Even knowing the jargon will help you in any of your exams or interviews. Okay, so gradient descent. There are different variants of gradient descent. One of the most popular learning algorithm is gradient descent. What it does? Yeah, correct. Like it is right, I already told you the answer. It is actually, the gradient descent is an algorithm, optimization algorithm, which is trying to find out the values of the constants or the variables in y equal to f of x in such a way that you minimize the loss. That is the only answer you have. You have to always remember when gradient descent, right? One picture should be always in your mind. Okay, so what happens is whenever you build a model, right, initially, okay, this is how you are getting. You have to come to this point. Okay, so it will be here. You have to come back to a point. Okay, you will have to choose your coefficients in such a way that you reach this point. Always remember gradient descent. This curve you remember. Okay, so you need to reach this point. Sometimes what happens is you will be running your algorithm iteratively over some number of epochs. Okay, you will be running your algorithm iteratively over some number of epochs. Okay, so for each and every epoch, the loss will be minimized and keep on coming to one point. At this point, you need to stop your algorithm. Whenever the loss is minimum, and then you will be giving out the A1, A2, A3 coefficients, and there your predicted and actual will be almost same. Your error will be zero. At one point, if you keep on running for more, it will actually increase also. Okay, so that point is very, very important. Okay, that is your gradient descent algorithm. If you see in any of your models, whenever you are trying to build a model, you will have to give all of these parameters. What is the loss function that you are choosing? Okay, and you need to also say what is the learning algorithm. Some of the examples are gradient descent is the basics, the one behind that, but the algorithm names are ADA, RMS prop. If anyone has tried building a machine learning algorithm, right? RMS prop, ADA are very, very common learning algorithms. Basic concept is that only, but there are variations of it. Yes, got it? Okay, we'll go to the next one. The last one, what is it? Yeah?
Evaluation.
Exactly. So evaluation parameters. So I have built a model. Okay, I have built a model and I am claiming that, okay, it is the best model that I have ever built. But there should be a metric in which you need to evaluate, right? All of you are studying, right? So you have exams. Why are you having exams? To evaluate where you are standing on your understanding. Okay, same way, for one particular task, there can be 100 models that can be built. Okay, so we need to evaluate against certain parameters or metrics which of the models are doing better. Okay, so the sixth one is the evaluation metrics. Evaluation metrics. Okay, so any one example of evaluation metric that you know? How do we evaluate whether the built model is correct or not? It depends on the type of algorithm we are building. Suppose it's a supervised algorithm. Okay, you have RMSE, MAE, MSE, mean absolute error, because you'll have to find out the difference between the actual to the predicted. Suppose you are building a classification algorithm. The metrics will be precision, recall, F1 score, AUC score, and so on. So depending on the type of, suppose you are doing clustering. What is evaluation metrics? There are many, but at least one or two you need to know. Celluloid score will be there. Celluloid score will be there. So depending on the type of algorithm that you are building, there are evaluation metrics for that. Okay, to say how good is your algorithm. Okay, so these are all the 6 parameters for whenever you start with a problem. These are all the 6 parameters or 6 jars that you need to consider. Data, task, model, loss function, learning algorithm, and evaluation metrics. Okay. Now I would like to tell what are the categorization in terms of machine learning. Okay, machine learning or artificial intelligence, right? So artificial intelligence is a bigger circle. Inside artificial intelligence you are having ML. ML is a subset of AI. So what are the categories in the broad aspect of machine learning? Okay, first thing is called as predictive analytics. Predictive analytics means what? Predictive analytics. Yeah, very easy. Predictive analytics, don't it? This regression, whatever you're saying, right? Regression, classification, all of this is coming under predictive analytics. Okay, then there is a set of area which you need to study is NLP, natural language processing. Initially, when you get into your jobs, right, you might be required to learn predictive analytics more, or even NLP also. But I'm just telling you, there are these categories, right? NLP is natural language processing. There is a third category now, which is called as a Gen AI developers. So generative AI is the third category now. Okay. So when I say predictive analytics is covering regression, any kind of a prediction, any kind of a forecast, right? Regression, classification, clustering, and recommendation. So even when I am working in here, right? So we are taking care of end-to-end, from requirements capturing till the deployment of the model. So in addition to these three, right, what we do is we have completely Python-based automations also. Python-based automations. So these are the four categories in which we are also working. Okay, any industry, when they are into AI/ML, right, there can be only Python-based automations. Ultimately, what you are doing is you are trying to automate the process. Okay, that is the main thing. What is the main objective? You need to automate the process without any human in loop. There should not be any humans. That is where people are afraid, right? If Gen AI is coming into picture and robots and artificials is coming into picture, humans will be replaced. That is the worry, right? That is called automation. Okay, but nothing to worry, like not all 100% automation is possible. There will be humans in loop. Our capability is like we can make better decisions than the machine, right? We will use the machines only in terms of compute, storage and other aspects so that it can do faster things for us. So whatever is a repetitive tasks, right, that we try to automate. Whatever tasks are not repetitive and which requires creativity, innovation, that will require human in loop. Okay, so always we should try to learn something which is creative, not repetitive. Okay, so the main aim of anything, any machine learning algorithm is automation in industry. Whenever you look at a use case, right, how we look at it is like, I want to automate. When I automate, what will happen? 10 people are working on that. All 10 of them will be, their jobs are gone. Instead of all 10 of them, what will happen? A bot will come and sit. I can call it as a bot. When I say bot, don't imagine a robot or something, but just a machine, a program that is running behind the screen will actually replace all of their 10 people's job. That is the main purpose of automation. That is where you guys are coming into picture. Okay, when somebody is trying to hire you, the main objective is automation. So how can you automate? These are all the ways. There is one more thing called as an RPA, which I will talk later. This is not coming under machine learning. It's called robotic process automation. Robotic process automation. Okay, so there are projects where we are using completely only Python for the entire automation. There is no AI/ML also in that. This is coming under explicit programming. We are doing explicit programming in order to automate the entire tasks. For example, people are opening the Excel file, they are doing VLOOKUP, they are actually, there are some 100 sheets in that. Each sheet they are reading, they are doing some filtering, they are doing some sorting and all that, right? So all of that can be automated. So you may ask me now one question. Ma'am, we can automate using VBA script also. Excel itself is having VBA. Why should I go with Python? Somebody, you yourself answer, na? Okay, some Excel-based automations, you can do it in so many ways are there. Okay, so VBA is one option. You can have macros written in Excel to automate the entire process. Why am I going with Python? You yourself think once. I am telling you the answer that Python-based automation for Excel is better than VBA scripts. One reason you tell me, you're like, good, your thinking is good. No, there is no machine learning at all. Forget about that. I am only talking in terms of automation. There is no learning at all here. I am saying there is one point why we go with Python-based automation rather than using VBA scripts or macros for Excel file automations. There are a huge amount of projects for us here. Okay, so don't think that if you are getting hired in a company under data science, you are always doing machine learning models. Machine learning models, you are building only 10%, 20% of the times. It won't sell for everything. Not only because of the time complexity and all, that use case won't add value because you are putting lot of resources. See, data science resources are niche. Okay, they are charged highly. Okay, they are charged. The clients are charged at very high rates. Okay, when they invest so much amount, right, for any small automation use case, just approximately I'm doing, they'll have to put around 1 crore if they want to automate. Okay, so if they automate to that extent, are they getting the benefits of that? Are they able to replace equivalent amount of employees? Question mark. You understand what I'm saying? 10 people, so resourcing, that is called resourcing. How optimized is that? I put 1 crore. Am I able to replace that many employees? You try to understand always from a business perspective. That is where there is a lag between academics and industry. So that is where we guys have to pitch it to tell you how we look at a problem compared to how you look at a problem. Correct? For your case, you are just thinking that okay, we can solve it using ML. But will it work? Will it fly? Is the question mark. Okay. Why? Because if I put 1 crore for automating using data science, am I able to get equivalent value in terms of replacing the resources? No, they are not getting. That's why data science solutions not always will fly out. You need to think of different ways of automation. Okay, so coming back to my earlier question, why do you think Python-based automation is better compared to VB? You can automate tasks across various things. That is one thing. Yeah, variety. The variety and the libraries with which it comes, correct. But I'm actually looking for one small platform independent is not the one. What I'm looking is just one word. Not space complexity. I think you told time complexity initially, right? Something, yeah, it is around that only, but I tell you it's called, in our jargon, it's called scalability. Okay, scalability, because in Excel file, now, if you're writing macros, see, you know how many rows it will support Excel file? Like, if I try to, if it is more than 6 lakh rows, right, it can have 10 lakhs and all. So if an Excel file says 10 lakh rows and you write a macro, it will take 20 minutes to process and give you the output, which is so much, right? You want to wait for 20 minutes to get something done? Okay, but with Python, scalability is there. Okay, it is very scalable. Irrespective, 20 lakh rows also, you are able to do within 20 seconds. That is the advantage with Python Pandas data frame. Okay, or if it is even bigger, right? If it's like a big data, I can go with a Spark data frame. Instead of a Pandas data frame, I can go with a Spark data frame. Just remember the jargon. Don't bother like, okay, ma'am is telling too many things. No. Okay, very simple. Excel file automation is taking 20 minutes. I would rather use Python Pandas data frame to automate, which will take around 1 or 2 minutes. Even the file is so huge. It's having 20 lakh rows. What I'll do is I'll go with a big data, Spark data frame. Same thing, same logic, everything same. Only thing is that multi-processing is possible. Whatever you are doing, whatever operation you are doing, right, it will divide into 3-4 splits, right? It will split the data into chunks or partition. It will partition the data, apply the process, combine the results. What is big data? Nothing. Big data is having only mapping algorithm. Okay. It's kind of divide and conquer strategy. Divide the data set into smaller chunks, apply the process on the smaller chunk, and then combine the results. That is called as a mapper. That is what internally happening. You need not do also. See, the beauty here is that you need to understand the concepts. Everything is there in the library. You use 4 to 5 lines of code, 10 lines of code, you are able to achieve the task. But the problem is you need to understand what you are doing. Okay. And if there is any problem, you need to debug. Okay. And if required, you need to interpret the results and fine tune. These are the essential things that you need to learn. Okay, keep in mind. Okay, so Python-based automation is better compared to any other automation because of the scalability. Okay, even the data, you can scale it to any number of records and so on. It will take only 20 seconds. not more than 20 seconds. That is the main reason. So we do a lot of these kind of projects, Python-based automation projects. Okay, then I'll talk to you about RPA before I come to these two. Okay, so don't think that data science is in boom, all these are there. So industry is all doing use cases around this. No, okay, that's what I'm telling. You need to have the problem solving abilities and creativity. Any person is coming with a problem, right? Any client will come to you with a problem. You need to understand the problem, understand the task at hand, what is the data availability and so on. Accordingly, take a call. First of all, you need to use this or not. This is just a tool only. You need to decide how you want to do so that they realize maximum benefit. With the minimum cost, what automation is possible, you need to think. Okay. So don't be with the mindset that, okay, I know this, then, okay, I'll write everything in ML, I'll build a model. No, that is not the solution. Every time ML doesn't work, that you need to keep in mind. Okay. So I can't, when someone asks you to show your nose, the simplest way you can show, not like this, right? So ML is like that. For everything and anything, don't apply ML. Put that in your mind. Okay. So what is RPA? RPA is a robotic process automation. RPA is a robotic process automation, which means that you are having bots in which the repetitive tasks are being taken care of. Okay, so this will not have any, I mean, there are so many RPA tools, I think you must be knowing, right? I mentioned three main tools of RPA: UiPath, Blue Prism, and Automation Anywhere. Having familiarity with these tools also will help a lot for you to secure jobs. Just I'm telling for your information. Robotic process automation, where you are, there is no much AML to that. Repetitive tasks will be automated. There are tools like UiPath, Blue Prism, and Automation Anywhere. Now we'll go back to the predictive analytics. So in predictive analytics, I'm saying everything that you're learning in machine learning, right, will fall into that. Supervised learning, unsupervised learning, reinforcement learning. So in supervised itself, we are having regression and classification. Both are coming under supervised. Clustering is there, unsupervised. Okay, hope you know, right? You are aware. Unsupervised, you will not have the class label. In supervised, you will have a class label. That means you know your output. Okay, if I'm assuming you're all still beginners. In supervised learning, there is under the supervision, like there is a training and testing, right? In supervised learning, there is a training and testing. But in unsupervised learning, there is no training and testing. Okay, you are just grouping. There is no independent, there is no output variable. Okay, in clustering, there is no output variable. Okay, and then there is this recommendation, like how I told, right? If you take this, then these are the other recommendations for you and so on. So all of these are coming under predictive analytics. There is a bunch of projects that will fall under this category, and these are all the things that will be done. This is called as classical machine learning projects. Okay, now if you come to the next one, NLP, there is a huge large chunk of projects that are happening in NLP. What is NLP? How did it come into picture? Natural language processing. And I forgot, even your deep learning algorithms also, I will take under this one. Whatever you want to use. Deep learning means, I'll tell you what is deep learning, but all of that is coming under predictive analytics only. Now in NLP, natural language processing, it's about the data is nothing but your text or images or whatever. The unstructured data, it can be either PDFs, text, Word documents and all, right? How do you make use, how do you pre-process through the engineering and then build models around the natural language processing, right? For example, in Google search engine, when I give something, right, it is actually giving you the next word. If I'm saying how to, it will tell you how to pass, how to apply for the GATE examination, give you recommendations, and you search from that, right? There is one use case I'm saying, sentiment analysis, one use case of NLP. Unstructured data to structured data conversion. For example, you have a PDF file, okay? You want to convert that unstructured data, any invoice is there, okay? That you want to convert to structured data. That is coming under NLP. There are a bunch of libraries around that. So NLP also, it's like natural language processing, natural language understanding, natural language translations also. You have Google Translate, right? So it is translating from one language to another language. Okay, so some example use cases here are that in YouTube. Okay, I mean any video that you are having, right? Summarization of the video, it's also NLP task. Okay, so these are all coming under any one example that you want to tell for NLP based on what I told now. Any examples that you are currently using that is forming under NLP?
Sentence transform.
Yeah, sentence.
Transform.
Yeah, sentence transformers. Yeah, all of that is coming under NLP. One other set I forgot is the computer vision. Okay, there is a separate area which is called as computer vision, where you are having video and images, right? Okay, you are doing whole lot of the self-driving cars. The use case of self-driving cars is a very good example for computer vision. Okay, just like see, what is the concept of computer vision? You are giving that machine learning not only the capability to see, you are giving one sensor for that. Here you are giving all the data, correct? In NLP, you are actually giving you speech and text. The Alexa and all, right? Speech to text conversion, text to speech conversion. Whenever in this computer vision, you are giving the machine, you are giving. So it is able to look and take a decision. Self-driving cars means what? You won't have a driver. Who is driving? Autonomous robot is driving. There is no one there. It is able to know the map. It is able to identify the objects in front of the car. Okay, but a whole lot of process is happening behind the scene. It's able to know like what, there are some sensors, ultrasound sensors. So it's able to know what is behind, what is in front. Object detection. It is able to detect the objects in front of it. And it is able to take decisions based on that. Should I go with what speed? Whenever there is a traffic light, it has to stop. So all of these things are happening because that we are giving the machine eye to computer vision. We are giving vision to the machine. And then we are giving all different kinds of data fed to it in order to make correct decisions. That is coming under computer vision. Okay, so we are having projects in computer vision also. So NLP is natural language processing, like I told you, understanding, translation and all. Then Gen AI, okay. So in generative AI, what is Gen AI? How is it different from all of this? Now recently 2 years back we have got, right, big revolutionary thing that happened is the Chat GPT. Okay, so what is Gen AI and how is it different from all of these? Something that came from the sky, or how is it different? Somebody is asking you what is generative AI, what do you say? It's a combination of everything. In a way, it is correct, but mainly you have to remember that generative AI is used for creating content. It is for creating content that doesn't exist. So generative AI. So it is generating content. Okay, it is closely related to NLP only. Okay, and a part of computer vision also. So it is closely related to NLP. So why it has a great boom is like it's nothing great. See, in NLP, there is something called as a bird transformer. Correct? So that was the basics. Okay. So it's like based, all of the Gen AI is based on something called as BERT and GNAN. Generative adversarial networks. Okay. So they have a generative component. There is a discriminator and a there will be two components, encoder and decoder, discriminator and generator. Okay, so based on that, it is able to differentiate and it is able to give you creative content. How is it different? It is nothing but, see, it is same as your NLP and computer vision. Okay, the models that you are bringing as part of this, the basics is based on GNAN and BERT. BERT is a transformer, right? GPT means what? Generative pre-trained transformer. Chat GPT, that means you can chat with it, like a conversational chatbot. GPT means what? Generative pre-trained transformer. GPT came from this word only, transformer. Basic structure or the architecture is a transformer. So you need to understand what is a bird, to understand what is that. Okay, basically to put like they have enhanced the same functionality that Google search was having, right? Okay, to generate more content. Why? Because of two things. One is because of that they have trained on Only difference is that it's also a model. Just like how we are building models, it's also a model. Only difference is that it has been trained on huge amounts of data. Correct? Huge and huge amounts of data, and the kind of processors that they use for that also are like GPUs. Okay, 50 to 60 virtual CPUs and GPUs they have used to train them. So it has costed them. Okay, now replacing that GPT, it has come DeepSeek, right? DeepSeek R1 and all, China has come up with that, right? So what is the basic thing there? That only difference is it's almost similar to all of these concepts, same thing, nothing new at all. Generative adversarial networks, that concept plus BERT, it's basically a pre-trained transformer. Only difference is that it has been trained on huge amounts of data so that it has a lot of learning. And then the compute, storage and the network bandwidths are not a problem at all. Because of the advent of cloud technologies, the advent of the pre-trained processors and all, right? Because of the advancements in all of the hardware, the networking, the bandwidth and the compute and storage facilities, they are able to train. They put huge amounts of money, millions of dollars, and they train a model which is able to generate content. So there are different kinds of things. Like for images, they are separate, right? Dolly. And also for different types of content. For NLP content, they had one transformer. For images, they have something. For video, they have something. For audio, they have something. To identify and label images, they have something. So, but the concept is same. Only difference is that it has been trained on whatever you used to do small, locally, right? Now you are doing it global scale. The scale only is the difference. Whether you are doing small or big scale. Okay, if you are cooking in a restaurant, you are cooking for 1,000, 10,000 people, big scale. If you are doing it at your home, small scale. That is the only difference, that's it. Nothing much. Already all existing concepts, existing things, they have built a big model. Suppose if you are building a model, right, usually it will not be pickle files or the SVD files, right? It won't be more than some MB or maximum GB. But here you have so much, you can't even store a GenAI model locally in your system. Okay, the model that they have trained. So it's the scalability is the only difference, nothing much. Okay, but the amount, the capability, right? Now in industry, what are the use cases that they are solving with the GenAI? Okay, what are the use cases that we are solving with GenAI? See, actually, what we are doing is, as long as we are having a dedicated environment, because in generative AI, I tell you, it's like an API call. Okay, we will have to call an API. And then we will have to pass the data and then get the answers, response back. So it is not allowed in all confidential, in all client applications. Okay, so we have to have a dedicated environment for that. And in that dedicated environment, we do the API call and we try to get the answers. So there are some certain constraints in industry when we try to use GenAI models. They are not applicable at all places. Okay, but some of the use cases are like invoice data extraction. I told, right? You upload an invoice, you get the output from that. Okay, exactly like 90%, 99%, all the structured data is extracted. Okay, or summarization of a video or audio. Okay, so few more examples of GenAI is that the conversational chatbots. Okay. So previously it used to take a lot of time to build a conversational chatbot, right? Now it's very easy with generative AI to build a conversational chatbot. So few examples are PDF data extraction, conversational chatbots, summarization of videos and audios, and so on. So these are all the different kinds of categories that we have in the machine learning. Now we'll go to the topic. Okay. Can we have this? Till now, any questions in whatever we discussed? Any questions till now on whatever we discussed? Till now, what we have covered is like what is machine learning? What are the 6 jars of machine learning? Okay, and broadly, if you are from an industry perspective, for automation purpose, what are the different categories of things that we do? Python-based automation, predictive analytics, NLP, computer vision, And Chennai, generative AI projects, there is also an RPA, robotic process automation that we do. These are all the things that we learned. Clear? Yeah. Now we will start with some of the basics of machine learning. Okay. Okay. 12:30 seconds. So we'll see the basics of machine learning and deep learning. So I'm assuming that you have all little understanding of the neural networks, right? So what are the things that we are covering as part of this neural networks? What is the basic concept of a neural network and so on? Feed-forward neural network. Okay, back propagation algorithm. Okay, in this only you'll be learning gradient descent also. And then convolutional neural networks and so on. So I think you have seen this one, right? So what is the basic concept of the neural network? Anyone? What is this thing here? See, what they try to do in neural networks. First of all, why should we have to go for neural networks when we had initially, right? We were using only structured data. Okay. And why we should have to go with neural networks? What is that we could not do without neural networks? Why should we have to go with neural networks? If you already know, see, initially we were like having supervised algorithm, unsupervised algorithm, and all this, right? There are certain things that we could do without neural networks. Like, for example, see, there is this AND gate, OR gate, NOR, XOR, and so on, right? So you give the input, you are able to get the outputs. Correct? So that used to be sufficient enough for solving many problems. Okay, all the predictive analytics part and all that. Okay, so the reason why we had to go with neural networks is that already you know that we are trying to build an approximation of the machine learning model, y equal f of x, right? So y equal f of x with all the logic gates that we have, right? Linear functions used to be possible. Okay, whenever there is a non-linearity, right, or very complex approximations that we need to take, right, then we were not able to do that. So when we had to consider non-linearity into picture, right, neural networks was very useful for us. We had to go beyond all of these gates, AND, OR, NOR, XOR, and all that, and we had to get something different. Okay, something that can give me a something that is able to approximate a complex function. It should not be linear. Okay, it should be non-separable. So for those, we had to go for neural networks. How they have invented is like they're trying to simulate our own brain. Okay, in our brain there are cells called as neurons, and they are connected with axons and dendrites. Correct? It's a complex network of different cells interacting with each other. But the basic concept was like so whenever I ask a question, right, there is someone who is giving me an answer. In the entire crowd, at least one person was trying to give me an answer. So that is called as one output simulation that I call. Okay, that will happen in your mind itself, right? When somebody asks you a question, everybody might have inside them like, see, this is how I learned mentally. Okay, everybody will have something inside like, okay, something going on, some activity processing going on, but you don't feel like raising your hand. Only at one point somewhere, I don't know where, something will fire and then you say, man, I want to answer. Okay, that is called firing of the neuron. When you are acting, right, when you are taking an action, okay, something is already going on in everyone's mind if you are listening. But only at one threshold, whenever there is some kind of an electrical pulse or signal that is beyond a certain point, then you will try to say, ma'am, I want to answer. That is called as firing of the neuron. Okay, so there are so many cases like that. Is the basic concept. Like, okay, there is an input, and whenever your electrical signal goes beyond a threshold, the neuron fires and you get the output. Beyond the threshold point, it won't give the output. Okay, so that is the basic concept there. They will take a perceptron. Okay, the perceptron is given an input x and the output is y. Okay, and there is a mathematical relationship between one single perceptron if they try to do now. It is nothing but sigma I is equal to 1 to n. Okay. Xi, correct? If you see this diagram, so there is this yeah, this is the cell, right? There are axons and dendrites, okay, and they are connected to multiple other neurons. This is a neuron. Okay, so we'll go to the next slide. We'll look at the. I'm actually looking at the formula. Yeah, this formula I wanted. Okay, so how they try to take one perceptron, how they modeled it mathematically. That you need to appreciate. How they mathematically modeled one working of a perceptron in our mind is this one. Okay, so they had an input and they had an output. So in between they had what? A bias and an activation function. So white cap is nothing but the prediction. White cap is equal to G of Wx plus B, where W is the weights and B is the bias or the threshold. Okay, so you can simply put as sigma I is equal to 1 to n xi. Okay, so it is nothing but the summation of all the different inputs. Now you tell me what are these weights and all that. What are the weights? Okay, how they simulated is that there are inputs, right? So there are different inputs, x1, x2, x3, so on. Every input has accordingly some weight also. Okay, weight associated with it. So sigma xi into wi from I equal to 1 to n. Say suppose there are n weights. That means x1 w1 plus x2 w2 plus x3 w3. Summation of all that is giving you your output. And I told you that it has to be greater than a threshold. That is where that bias is coming into picture. When you sum up all of that, right, and you add a bias, you add some threshold value. Threshold is nothing but the bias. If you add a threshold, it should be greater than a specific value. Then you are getting the output by. Otherwise, you are not getting the output by. That is how they have beautifully modeled a perceptron of our mind, and they brought in the basic logic of a perceptron. With a single perceptron, you are able to realize all the small things, and or not, XOR and all that. Okay. Now what happens? How did they enhance the neural networks further? How are they able to enhance the neural networks further? There is an input layer, there is an output layer. There are all these weights and biases. Okay, yeah, hidden layer is there. Hidden layer is nothing but only this part, the activation function with that, right? So if the number of hidden layers are increased, okay, then what happens is that you can model complex functions instead of linear function, right? Non-linear functions and more complex functions can be realized. So we'll go back to a simple neural network. Let us see the concepts of the neural network. So ANN is what? Artificial neural network is an integral part of artificial intelligence and the foundation of deep learning. Okay. We will see in a minute what is the difference between machine learning and deep learning. And so what is the main objective of ANN? Is to develop a system to perform various computational tasks faster than the traditional systems. So ANN is different in two aspects. One is it is able to model non-linear functions, and also it is faster in terms of convergence. What is convergence? I told you already, you have to always remember this word convergence. Convergence is nothing but when you are iterating the algorithm over a period of time, okay, and you are running over some number of epochs, there is a point where your loss is minimum. That is where the algorithm is said to have attained convergence, and you need to stop at that particular point. Okay, so ANN are very good and advantageous in two aspects. One is they are good with modeling complex functions. The second thing is that they are able to do things faster. So why not adopt, right? So what are the tasks of an artificial neural network that you can do? Pattern recognition, classification, optimization, data clustering, forecasting, fraud detection, risk assessment. These are some of the use cases that you can do with neural networks. So how does a neural network look like? There is an input layer, there are hidden layers, and there are output layers. If you look here carefully, right, every input is mapped to every other in the hidden layer you see. It's going everywhere. And there are weights. Till now we have not given here, there are 2 inputs and 1 output. Okay, and there are also weights associated with each of those arrows. You need to understand, there is a mathematical operation that is being performed. Okay, if you look at a video, right, you will understand how input weights over a period of time, if they iterate, how you get the output and so on. So this is the mathematical function. Okay, using a single perceptron. This is the mathematical function that they are building using a single perceptron. If you see there, right, it's like y equal to mx plus c. Correct? The equation is almost similar to wx plus b, where w is the weights, x is the input, b is the bias. Remember for sure, this is very, very, very important. Okay. So, the neuron, it takes weight, there is an input. So what is a deep neural network? If the number of hidden layers are increased in an ANN, right, artificial neural network, then it is called as the deep neural network. So these weights, what are the weights? They explain the strength or importance of the connections between 2 neurons. Or they will give you the importance of the input variable. Okay, you can change it. For example, like if I'm calculating based on certain input features for output feature, right? Every input feature you are studying, right? The number of hours you are studying, or the number of certifications you are doing. Okay, all of these are input features, right? In your placement also you have a weight associated with everything, correct? That weight only we are talking here, nothing different than that. Okay. For your placement, yeah, somebody has a question? Yeah, for your placement, right, what they are doing, they are taking different metrics. How many GitHub repositories you are having, how many hackathons you have conducted, how many hackathons you have participated in one, and how many NPTEL courses have you done, all of this, and everything has a weight. Okay, what is your CGPA, what is your 10th score, what is your 12th score, what was your medium posts, what are the voluntary operations that you have done, what are the social activities that you have undertaken. Okay, all of these carry weight, not all are equally weighted. Maybe your 10th mark may not be that important. How many internships have you done that may be having higher weight? Exactly same thing here also. There are so many inputs and each input is given a weight so that we can actually make the model understand, saying that okay, this is, and we can actually set that weight also sometimes. Initially when we start with a weight, we can initially assume that all are equally likely, all are equally important, and say everything same weight, or I can even introduce a weight bias if I want to. That is how I can build my neural network model. Okay. So there are something called as bias activation function. Okay. So what is bias? As I told you, right, it is nothing but that threshold value where beyond which only your output will be coming. It should be greater than some value. It can be 0.8, 0.7. Okay. See, what happened is that mathematically they have modeled using the brain, but don't think that there is something biology in this. It's all fully mathematics. That's why maths play a very important role. You just have input and that summation function, right? And you are fixing a threshold. Bias is nothing but you fix a threshold. You say that my threshold I can fix also sometimes. 0.5, 0.6, some value in between 0 and 1. If that is greater than that only, it will fire. Okay, you can fix your bias or the threshold value. Okay. So what are these activation functions? There are numerous activation functions which we are going to talk about. Okay. So nothing but mathematical functions. Cat h, okay, sigmoid function, and so on. Okay. ReLU function. These are some of the softmax, some of the activation functions that we'll be using. Mathematical functions, right? So your activation functions are basically divided into 2 types. What are they? Linear activation function and non-linear activation function. What is a linear activation function? Whenever your output is in the form of a straight line, they are called as linear activation function. Whenever the output is not in the form of a straight line, curved, okay, then it is called as a non-linear activation function. Some of the activation functions are given here. Sigmoid, it's also called as logistic activation function. Tan H is tan hyperbolic function. ReLU, rectilinear linear output. Softmax. Okay, how do they differ? They are nothing but in an X and Y graph, you can draw them, right? There is a function, mathematical formula for that. If you take sigmoid, right, it is nothing but 1 by 1 plus e to the power of minus x. You keep on giving the values of x and you draw the plot, right, it will come. So everything has a, it's a y is equal to f of x. You have a function and that you are giving all x values, and then you are trying to find out your y. They are nothing but mathematical functions. So what is the use of an activation function? That is actually helping your output will be anything like, it can be anything, any curve or anything, right? When you give your activation function, right, we are making it follow certain path. Okay, we are trying to fit your output into one path, trying to approximate that. So activation functions are very important in terms of that getting your output and fine tuning that, right? See, here are some examples of sigmoid. The red one is a sigmoid function. It is ranging between 0 to 1, right? Value is ranging between 0 to 1. Tan hyperbolic function. Okay, it is ranging somewhere in between -1 to 1. There is this ReLU. Okay, ReLU function, you have two types of ReLU functions. Okay, there is a ReLU and a leaky ReLU also. You can use any of these functions. So one of the most important activation function is softmax. So what is the softmax activation function? It takes in a vector of raw outputs, okay, and then returns a vector of probability scores. Okay, so the raw inputs that it is taking and then it is giving. If you notice here, right, the output is always positive, and if you sum up all the outputs, it will be 1. Basically what it is nothing but it's a probability. Okay, so when you are trying to say whether we are building a machine learning model and we are trying to say it's a cat or not, okay, it's a binary classification. Okay, binary classification means what? 0, 1. Ultimately, in machine learning, everything is like number. Okay, we will convert into yes or no, but it is 0 or 1. If it is a cat, it is 1. You can make anyway. Not a cat, 0. Okay, somewhere in between 0 to 1, right? I will fix a threshold there. I will say, depending on how it is working, right? I will fix my threshold as 0.5. I will say anything greater. I will not get the output as 0 and 1. Whenever I apply an artificial neural network for predicting or identifying whether the given image is a cat or not, I will get the output in the softmax like that, 0.24, 0.664. Then how should you be predicting? I will fix my threshold. I'll say that if it is greater than 0.5, give it as a cat. Less than 0.5, give it as not cat. That's why only it is not 100% accurate, it will go wrong. What are these all? These are all probability scores. And what is the basics of probability? Sum of all probabilities is equal to 1. It will lie between 0 and 1. They are all positive. Okay, so you are fixing that value. You can put it 0.5, 0.6. You can adjust according to the accuracy. If you feel like you are putting 0.6, anything 0.6 you are getting as cat, not cat. That is giving you like 90% accuracy. Very good. Any machine learning model that is working in real time, having 80 to 85% more accuracy is a very good one to consider. Anything that is less than 80-85, now these days the accuracy scores have improved a lot. Okay, again it depends on the data and all that, but you are getting around 90-95%. Okay, so how you are fixing? You are fixing the threshold value of that softmax function. Okay. So these are all the different activation functions and how they are looking. Mathematically, it's just a graph. You are learning in electricals. It's a signal there. Okay, sigmoid and tan H, ReLU, softpress, Gaussian, and so on. So deep learning, in deep learning has neural networks which performs unsupervised learning from unstructured data. The learning can be either unsupervised, supervised, or semi-supervised. Okay, deep learning means all the three: supervised, semi-supervised, unsupervised. All of that we can do using neural networks. Now, take a moment and tell me the difference. I think next slide is explaining you the difference between machine learning and deep learning. Take a moment and think about what is the difference between machine learning and deep learning. When neural networks are coming into picture, what is the difference in terms of building a model? How it is different? Can anyone try to think? Yeah, exactly. Super. That's it. That is what I wanted. Automatic feature extraction. Previously, when deep learning was not there, right? We are not building using deep learning. No neural networks were there. So we had to do that feature extraction, right? It is manual. That is one main point. There are other points, but yeah, the main point of deep learning is like it will automatically extract the features. When I give cats and all that, so it is identifying the patterns and storing, and it is itself is making sure. I need not tell it, right? I need not explicitly tell what I know. So automatic feature extraction is the main difference, but there are other things as such. So here they are saying DS versus ML. So in machine learning, what is happening? So the example, same thing, right? Cat is there. In machine learning, what you are doing? Feature extraction, classification, The output is cat or not cat. So in deep learning, what you are doing? So you are having an input layer, hidden layer, output layer. It is depending on the weights, biases and all, huh? And you fine tune your algorithm. Then you are able to identify it's a cat or not. So feature extraction is done automatically. You need not. But if you are doing in machine learning, you need to identify what features you need to consider. Both ways you can solve the problem. Which is more efficient? Deep learning is more efficient. And it's easier. Okay. So I told you, right? Deep learning mainly will come neural networks. Deep learning means you have to keep always in your mind neural networks that you are using. It can be anything, feed forward, back propagation, whatever. To learn better and extract features from the data, deep learning models are used. So what is this one? The performance. When you are having the data, and what is the performance for deep learning and traditional machine learning algorithms? So what happened in terms of performance? Whenever you are using deep learning models, right, the performance is more in terms of faster accuracy and speed, right? Faster speed. Deep learning algorithms are working better compared to the traditional ML models. Very high computing power and require graphics processing to run. Okay. So they require GPUs. The deep learning models require GPUs instead of CPUs. So what are the types of neural networks? What are the different types of neural networks? Now that we have studied, right? There's an input layer, hidden layer, and then there is this output layer. We have bias, we have activation function. There are weights for all these inputs. What else? So there are different kinds of neural networks. They are called as feed-forward neural network, convolutional neural network. Then we have recurrent neural networks and autoencoders. Even there are more, but these are all the basics. Okay. So we will look at feed-forward, and then we will take a break. Okay. So in a feed-forward neural network, anyone who can tell me the basics of feed-forward neural network? Take a moment. You can go through the slide also. Can you tell me the essence of a feed-forward neural network? Anyone who can summarize? Yeah. So that is one point. Feed-forward neural network is a fully connected network. I wanted to see this diagram. That's why I'm going to the next one. See, this is an example of a feed-forward neural network. Minimum, it will have one hidden layer. It can have even more also. In feed-forward neural network, always the input and the weights travels from like in one direction only. It cannot go in the reverse direction. And it's a fully connected network. And there are no loops. That are the main features. Fully connected in the sense every input layer is connected with the hidden layer. If you see there, right? From the input layer, variable is number one variable, right? It is connected to every other in the hidden. Okay, it need not happen with all other networks. In a fully feed-forward neural network, it's a fully connected network, which means that input is connected to each and everything in the hidden layer. Whenever you draw the diagram also, right? You have to actually connect each and every input to the output in all different possible combinations. Okay. And it's fully connected. There are no loops. Always the weights and biases and all the activation function travel from one direction only. Okay, forward direction. That is why it's called feed forward. Okay. And what is? What are the use cases of feed forward neural network? What are use cases you can use? Classification, face recognition, speech recognition, computer vision. Okay, all of these things you can use a feed-forward neural network. Oh, sorry. So, this is an example of feed-forward neural network. Okay, it is the most widely used algorithm for training artificial neural networks. This is what I was talking about. Back propagation, I'll tell you one thing. It's very, very important to concentrate some time on back propagation algorithm. Why? Any idea? See, this is like a certain things in this way, in deep learning. Some of the papers that were published were like a revolution. Okay, one of them is this backpropagation algorithm. Okay, it has created a revolution itself. So we need to spend some time understanding the backpropagation algorithm. It's nothing but the main aim is that we need to minimize the error rate. How it is being done is very important. I don't know if I will have time. We will take a break at 12:30. But I think even if I am able to tell or not, but it is very important for you guys to understand what happened in a backpropagation algorithm. How it is able to minimize the weight, how it is able to propagate the weight back and able to minimize the error, able to minimize the error and then we kind of optimize the solution, right? The entire concept lies in the backpropagation algorithm. Anyone who can summarize? One or two lines? Keep in mind that it's very, very important. Students especially who are going right for interviews, backpropagation algorithm is very important. Whenever they ask anything on deep learning algorithms and deep neural networks, the first thing is these two things are there. Gradient descent is there, backpropagation algorithm are there. This has created a revolution. Like if you are not propagating your weight, I mean, you are not propagating your values back, right? There is no backpropagation. You can't optimize beyond a certain value. Okay, your error you cannot optimize. Okay, they used to propagate the error back and then they will adjust the weights and the biases in such a way that we are obtaining that minimum error. Okay, that is the main concept of backpropagation algorithm. Because of the invention of this only, we are able to actually minimize the loss and so on. Okay. So, now we'll take a break here.